So let's get started. So I'm just going to go File, New, and we're going to start with a fresh scene. So the first thing we're going to want to do is to create those kind of explosions is we're going to want to write some code that's going to serve as kind of our central location that we're going to be able to then go to whenever we want to create an explosion. Because we might choose to create an explosion, one of those light rays, when something collides, or maybe when we push a button. So there's all these different kind of cases, and so we want to centralize the code that will cause that to happen. And so to do that, what I'm just going to do is I'm going to undock the browser. I'm just going to right-click, and I'm going to create a new, under Scripts, Global Script. So this is a script that lives inside our space, but it lives in a centralized location. We can access this from anywhere else, and it's in here that we're going to write all the code to kind of create that light explosion. And so I'm going to rename this and call it the Explosion Manager. This is essentially our script that handles explosions. And inside here, there's some, when we edit it, you'll see that there's some default code. We're just going to erase that. And we're going to just define a new function. I'm just going to call this function global script explode. And we're going to have this explode function take in two parameters: the position of the explosion, so the explosion position, and maybe a color, the explosion color. So our explosion color. And so these are the two parameters that we're going to want to call. And for now, I'm just going to print a message, just so we can see this function, how we're going to call it, and how that's going to work. And so now what we have to do is we're going to create an object that when we push a button, it's going to call this function. And then from there, we're going to fill out this function to make it actually perform that explosion. So I'm going to close this script, and I'm going to just create a simple object in the space. I'm just going to create a sphere in this case. And on this sphere, I'm going to go and add under Events. Actually, no, I'm going to create a player controller. So I'm going to hit on the sphere entity, this little button here, and I'm going to create a new player controller. And the player controller is just basically a system that lets us create script that correlates to user input. So whenever the user pushes a button on the VR controller, or maybe on your keyboard, your mouse, or gamepad, all these things will this is the place to kind of receive those inputs. And so clicking on the player controller on the right-hand side, I'm going to create I'm going to hit this little button here, this little tiny plus button. I'm going to create a new on-off button user input. So this is basically whenever the user pushes a particular button, we'll get notified of it being pushed and it being released. I'm just going to give this a name. I'm going to call this input explode. And we're going to set a default binding for it. So in my case, I'm going to just click on this. I'm going to hit A on my keyboard. So every time I push A, this code is going to get called. This onExplode event is going to get fired. So now I'm going to click on onExplode, and it's inside here basically that we want to call that explode function that we just added to the explosion manager. So how do we do that? I'm just going to drag and drop this explosion manager into this script here, and I'm just going to call the explode function on that. And the explode function wants two arguments. So we're going to pass in our world position. So that's whatever this object, wherever it happens to be located, that's going to be the location of that explosion. So we'll be able to move this around and cause that explosion to happen wherever we happen to position it. And then the second parameter that we added was a color. We want a color. And we're just going to pass in our own color, which means by doing this, we can now set this color of the object. We can set the color of the object, and the explosion will match this color. Well, because it'll take the color of the object, basically. And the other thing we're going to want to do is, you'll notice that onExplode takes in a parameter, in this case b value. This value will be true when we push a button, and it'll be false when we let go. And so we're only interested in when we push down on the button. So I'm just going to say if b value is equal to true, then. And so that makes sure that this code will only call when I push the button, not when I release it. There are many cases where releasing it is useful, where you want to know that. So for instance, maybe when you're holding down the button, a timer begins, and when you let go, it stops that timer. But in our case, we're only interested in triggering that explosion. So we have it now set up so that whenever we push this button that we've assigned to be the letter A in this case, but the user can go and change this under Edit Preferences. You'll see that this input that we just created lives inside here, and you can rebind that here to whatever you want. But by default, we're assuming when you push A on your keyboard, this function will get called, which in turn will call the explode function that we wrote already inside here, which I'm going to show you here, which will simply print the message explode. So let's see what happens when I hit play. Oops, we throw an error. Oops, I misspelled get world position. hit A, and you'll see that every single time I hit it, explode is called. That function that lives inside of our explode manager is called. So that's what we want. We now have a nice, elegant way to go from this object that is currently the player controller object in this space to call a function that lives in our centralized script that lives inside our library here. So we're going to go back into this explosion manager and fill out this function. Now the first thing we're going to want to do is we're going to want to draw all these lines that burst out from our location. So the explosion position in this case will be the center point of this sphere, and its color in this case will be white because the sphere is white. So we basically want to emit lines that come out of this position. And so we're going to create a new function called draw line. It's going to live inside this global script. You got to remember to do this. By putting functions inside this global script namespace, it ensures that it can then we can call on this object. When we drag and drop this object into it, we can call these functions. If we had just created this, if we, for instance, create a function like this, if we just say, oops, I hit play. If we simply create a function along the lines like this, draw a line, let's say, we can't access this function from this other object because it won't be able to find it. We have to stick it inside the table, in this case, that lives inside this explosion manager. So long story short, you just have to precede it with global script in this case. Now we can safely call this function from this other object because it can find it. It lives inside this object's table. Okay, so let's go back and let's write this function draw line. So a line drawing function generally takes in two values, a start value and an end value. So this would be a vector 3 that represents the start location of our line, and this is going to be the end location of our line. So our goal now is to just kind of fill that in with a cylinder, basically a cylinder that starts at v start and it ends at v end. So let's go ahead and add that cylinder to our space. I'm going to just draw a cylinder that's going to represent our line. So I'm going to use a cylinder primitive, and I'm just going to, for now, just draw it to be an arbitrary height. So this is now what we're going to be making copies of whenever we want to create a line between 2 points. We're going to make a copy of this cylinder and then adjust its parameters so that it goes from one location to the next. And so another thing we have to do is we have to kind of make a few alterations on this cylinder to ensure that we can easily kind of set it in script so that its world position will represent its start and its length will represent its end. So by default, when we create a cylinder, there's a couple of things that happen. Its center point acts as its position. So if we were to say set world position to our start position of our line, it would put the center of our cylinder as the starting position, which we don't want. We want the bottom of the cylinder to be the starting position, and then the ending position will be the top. So to do this, what I'm going to do is, first of all, we're going to remove the rigid body of our cylinder. We don't want this to fall in physics. We don't want it to fall down and collide with other objects, so I just removed that rigid body. And I'm also going to remove this trigger activating attribute as well. We just made this kind of into a really simple cylinder that has no additional attributes. Now, if we expand Mesh Model, under Mesh Modifiers, we're going to add a new Mesh Modifier called the Vertex Transform. And what this is going to allow us to do is it's going to allow us to basically retransform this into a slightly different frame that'll make it easier for us to parameterize it and set it as the line between 2 points here. And this will be a little bit more clear in a second, so just bear with me. We're going to just make these changes, and then we'll understand it better once we write the script. So the first thing actually we're going to do is we're going to go to the cylinder shape, and we want to make sure its height is set to 1. And this is important. A little bit later, we're going to be using scale to set its height. So let's set the height to 1. And then again, back in this mesh modifier that we just added, the first thing we're going to do is we're going to rotate this thing 90 degrees. So we're going to set the rotation to 90 degrees. And the reason why we do this is that now we can use the look at function to properly orientate this thing to look at another point in space. So when the rotation is set to 0, by default our cylinder points up. It points at the up axis, basically. It points at, so if you can think of it as by default, without any rotation, it's facing, so to speak, the vertical axis. But we want it to actually face the z-axis, because the z-axis is our looking at axis. That's the axis that we'll be able to just simply call a function called look at, and it will properly orientate the object with respect to the z-axis. So long story short, we have to rotate it by setting the rotation value here to 90 degrees under the vertex transform. And then the next thing we want to do is we want to offset our z value here in this vertex transform position to 0.5. And again, the reason why we have to do this is that we set the height of this cylinder to 1, and by setting this offset to 0.5, we effectively shift the center point of the object, the origin of the object. We shift it to the bottom of it. And again, this is going to allow us to set this as the starting position, and then we'll just have to set the height, basically via the scale, to match our distance. And we'll see a little bit how that all works in a second. But long story short, to make a line, to convert a cylinder into a kind of something that we can easily code as a line, we want to do two things. We want to set its height of the cylinder shape to 1, and we want to create a vertex transform under the mesh modifiers, and we want to set a 90-degree rotation for its rotation parameter, and a 0.5 offset for its position. And again, 0.5 is half the height in this case. So once we do all that, we now have this object that we can very easily now in script position and then adjust to create a line between 2 points. So the first thing we're going to do inside this draw line function is I'm going to drag and drop that cylinder that we just created, that line, which I'm going to actually rename to line. I'm going to drag and drop this object from here into our script. And then the next thing I'm going to do is I'm going to clone that as a shared copy. Clone as a shared copy. So this is going to make a copy of our line object. So because that allows us to create lots of different lines. Each one is being derived from this initial one that we drew. And we're going to store that inside a variable called copy. And the next thing we're going to do is we're going to set the copy's start position equal to or its world position equal to our start position that we pass into this draw line function. So now it will be positioned on the start position of our object. So in this case, when we hit a button, it's going to get placed like that in this case. So notice again that its origin, which is where that position will determine where to go, where that offset for when you call set world position, where that actually will end up going, will end up being at the start position on our object itself. And the last thing we need to do is we need to set the height to match wherever our endpoint is going to end up being. And so for that, we're going to actually use the scale of our cylinder. So one way to do it is to think of it by setting the height. But for efficiency reasons, it's better if we use the scale of the cylinder. And we've actually set this all up by putting this offset and by setting the height to 1. We've set it up so that we can actually just make adjustments to the scale, and those will be exactly equal to the distance in the space that we want to set, because essentially it's multiplying 1 in this case, or whatever this number is, with the height of the object. So the height is 1, and so now we have a nice direct one-to-one mapping between actual distance values through the scale parameter and the height of this shape. And so we're going to just keep it at 1, but we're going to basically set the scale of this now to be the length of our line. So how do we calculate the length? We're just going to take the v start, subtract it from v end. These are two vector 3s. And we're going to take the length of this, and we're going to just store that into a variable called length. So this just takes our vector 3, which is our starting position, or world position of the sphere in this case, to the end position, which we're going to calculate in a second. And it's just taking the length, the magnitude of that vector, that resultant vector that's created by subtracting those two. And we're storing this variable length, and now we're going to set the scale of our line primitive, of our cylinder, to match that length. So I'm going to just set the world scale to vector 3, 1, 1, length. So again, that's just literally going in here and setting the scale value of this equal to that, and the other two parameters need to be 1 and 1, because if they're not, then this just goes away to 0. You won't see it anymore. So we got to make sure those are 1, and then we're going to adjust this equal to that length. And I need to close a parenthesis here. So set world scale on our copy, so we're going to position it dynamically to the front, our copy, and then we're going to set its scale equal to the length of our end position. So now, whenever we call this explode function, we want to call draw line. And so I'm just going to call self::draw line. We're going to pass in our explosion position as our starting position. And then as an ending position for now, let's just take our current position, and we're just going to add in vector 3, 0, 2, 0. So what that's just literally going to do, and we're going to update this in a second to be random, but it's going to just take that position, that's the sphere's position, and it's just going to add in an offset that's going to be 2 units above it. So it's going to create a line that just comes straight out when we call this explode function. So let's see what happens when we hit play. Oh, right, and straight out in this case is actually going to be, well, this thing is rotating, but the straight out in this case is actually going to be along its since we rotated it 90 degrees, it's going to actually be along the z-axis now. So that's correct. That's what we want. So now every time we hit the button, it creates a line between that position and the position in front of it. So the next thing we need to do is we want to choose a random vector for this. And so instead of choosing a fixed vector, we want it to be random because we want the explosion to kind of come all around this, kind of explode away from this sphere. So how do we create a random vector? Well, I'm just going to create a function. This just lives inside here, so I can just say function get random vector. We don't need to get a random, yeah, let's just do a random vector. We don't need to stick this inside the global script table because we could do this if we wanted to. That means we can then access this function from other places by calling on this explosion manager the get random function value, random vector value. But by just doing this, it only lives inside here. It can only be accessed within this script in here, which is fine. That's because only this is going to be calling this function. So we're going to return a vector 3, and we're going to just create a random vector by just using the Lua function math.random. And the Lua function expects a range. So we're going to go from -10 to 10. So in other words, 10 units along one axis and 10 units along another axis. So it's going to just create it's going to choose a random value between -10 and +10 in world space units. And we're going to actually do that for all the 3 axes. So along the x, y, and the z axis. So this is going to return a vector 3 with a random value from -10 to 10 along the x axis, along the y, and along the z axis. So we can now, if we add that, what gets returned here to our position in world space, we're going to get a position that no matter where this object is positioned will be randomized within that like 10 radius of 10 around this, or actually, yeah, -10 to +10, -10 along each axis will be randomized around the position of that sphere. So I'm going to take that explosion position that's passed into the air, and I'm going to just add in this get random vector. And this is going to be our end pass for our line. So now instead of passing in this, I'm just going to pass in that as our end pass. So just say take the position of that sphere, or wherever we happen to say we want to create an explosion, and add in this like offset vector, which we calculated to be this, which is random. So let's see what happens when we hit play, and we push a button. And I'm going to actually remove the rigid body of this sphere so that it doesn't fall, so we can just keep it in midair. I'm going to remove this as well. And so it is actually always going in one direction. Let's see here. The end. Oh, and okay, right. The last thing we also have to do is not only do we want the line to, we don't only want to calculate the length of the line. There's one other thing we need to do. We need to actually orientate it with respect to the starting position and with respect to the end position. So we just need to make it look at. So we're going to just take copy and we're going to say look at, copy the end. That's the other thing I forgot to mention. So this thing is going to position it at the start location, which is where our sphere is. This is going to set its the length of it to equal the distance between the start and the end position, and this is going to orientate it with respect to the end position. So it's going to position it, and then from there look at. And because we rotated it 90 degrees using this vertex transform, this will now using this function will properly orientate the cylinder in the direction we want it to orientate. So now let's hit play and see what happens. So notice every single time I hit a button, it now will choose a random location around the sphere, and it will orientate that sphere to look at that endpoint, and will set the length of that line equal to the distance between our start position, which is the sphere, and that calculated random end position. Okay, so this is a good start. This is what we want. Another thing we might want to do is we might want to animate the line. So instead of it just kind of appearing immediately, it will animate. So it will extrude out from our sphere into the radius, into that random endpoint. So to do that, instead of setting this world scale explicitly, we're going to actually set that using our animator function. So we're going to go through our animation, and we're going to say get animator. We're going to create a scale key clip, passing in our copy. So this is basically saying I want to create an animation keyframe animation track or key clip using our copy. In this case, the copy is our line. So we're going to basically say I want to animate the line's scale parameter. And then we're going to just add a key. And this can be however long we want. And I'm just going to do 1/10 of a second. And we're going to animate it to, instead of setting it to the same value that we passed in before. So it's basically going to say animate that to this location here, this 111. And before we do that, we might also want to set it explicitly, the world scale, so it starts at 0. So I'm just going to take that copy. I'm going to set the world scale to 110. So we're going to start here. It's going to basically so it's going to make a copy of it. It's going to immediately set the copy's height to 0, basically, so you don't see it. And then it's over the course of 1/10 of a second, it's going to animate it to this length here, to this parameter here. So we're going to maintain the same 1:1 scale for the x and y axis, and we're going to set the z axis to the length, just like we did before, but now we're going to do it through this key clip system. So let's see what happens when we play. There we go. So now they extrude out every time we hit a button. Okay, so now what we need to do is we want to create an explosion of these. We don't just want to create one every time we push a button. We want to create kind of a burst of them so they all merge out of this location. And so to do that, we're going to be creating a timer that's going to repeatedly call this kind of explode logic here. And then each time it'll choose a new random vector, and then we'll call it again, and so forth. So we want to do this using a timer. We don't want to. We could merge 5, or we could do 30 all at once, but it's always better to use a timer so you spread out the work that has to occur, in this case creating a line and extruding it out and all that stuff across multiple frames. It just generally runs better if we do it this way. So I'm going to create a timer. So before we create the function, I'm going to say get animator, just like we did before with the animator. The animator object, if we hit F1 on this get animator function, you can see that animator is this object that has all these animation functions in it, and it also contains this function to create a timer. And a timer is just something that will wait a certain amount of time, and then we'll call a function in our script, which is what we want here. So I'm going to get animator. I'm going to say create timer, and the first parameter is what we're calling on ourself. We're going to be creating a timer that's going to be called on ourself. This is our function that we're going to be calling, so on explode, I'm going to say, and this is how long to wait between calling this timer function. So we're going to wait 1/10 of a second, and then we're going to call our function, which is then going to extrude out this line. And the last parameter we're going to have to do is do comma true. And what this says is normally when you create a timer without this parameter, it calls this function once, and then it stops. We want it to continually call this function every 1/10 of a second. And so each time it gets called, we're going to extrude out a line. And so to make that happen, we're going to have to call this create timer function with comma true. That's going to repeatedly call our on explode function until we decide to call stop on it. And we're going to have to basically build that in so that it doesn't go on forever. So the next thing we're going to do is we're going to implement our on explode function. So global script on explode. And what we're going to do is we're going to move the code here that draws our line, and we're going to just move that. I'm going to copy and paste that into here, basically. So now our timer is going to, when we call this explode function, it's going to create a timer that's going to repeatedly, every 1/10 of a second, call this on explode function, which is going to draw a line. Now the problem is that our explode function takes in our color and our position, and there's no way to directly transfer those parameters into this timer function. So we need to kind of do that ourselves. So to do that, I'm just going to create kind of these global variables here that are going to store our explosion location. So I'm going to say the explosion. We want to give this a different name than the argument that's passed in. So I'm going to say our the explosion world pass is, and I'm just going to initialize this to a default variable by default, and I'm going to say our v explosion world color. And I'm just going to initialize this to just a default color value. Just black and transparent is basically what it defaults to. And so inside our function, we're going to basically store these values that are getting passed into this explode function. We're going to store them into these variables here, and then we'll be able to access these variables from this function, basically. So I'm just going to store that inside here, and I'm going to store this world color, the explosion color, into here. Actually, for completeness, I'm actually going to rename this to C explosion world color. And so now inside our onExplode function, I'm going to be able to just use this instead. This is the value that's going to be in our global value, and the color, I'll be able to do that as here as well. So the other thing we're going to do is right now we're actually not using the color. So well, actually, let's see what happens now if we hit play. So it's going to repeatedly call this, which is going to call this, which is going to use that stored value to then calculate our end pass. And the other thing we have to do is also pass that value into our draw line start position. And nothing happens. Let's see why. Oh, right, because I didn't push a button on my keyboard. Okay, so I hit a button, and now it's just repeatedly calling. It's never going to stop. It's just going to keep calling, which is no good. It's kind of neat looking, but this will eventually, will start to get slower and slower as it creates more and more of these things. So we got to have it stop. So let's have it just draw maybe 30. A 30 will be good. 30 of these lines. And so to do that, again, I'm going to use another global variable that's stored in our table. We'll call this line count. And I'm going to initialize this to 0. And then inside here, basically whenever we call explode, we're going to initialize this to 30. And then we're going to subtract 1 every single time this onExplode function happens. And then when we reach 0, we're going to stop our timer. So here we're going to say line count is equal to line count minus 1. And then when that line count reaches 0, we're going to call stop. Get animator stop timer. And this is exactly the same, and I'll show you in a second what those parameters are. Those match these parameters here. So when we call create timer, these basically are how we identify the timer to then be able to stop it here. And the one other thing you might want to do is copy this stop function and do it before we call create timer, because we can already have the timer running from a previous. If we happen to call explode twice before it's done emitting all of the lines from the previous explode call, we just want to force that timer to be stopped before we create a new one. So this will now only emit 30, and when each time it'll subtract 1 from our line count value that we initialized here. It's a global variable that can be globally accessed by any function inside here. So we're going to initialize it to 30. We're going to subtract 1 each time onExplode gets called, and then when it reaches 0, we're going to stop the timer, which will stop calling this onExplode function. So back to here, I'm going to hit the button, and we wait, and after 30 are created, it stops. So that's what we want. And one other thing we might want to do here, so the other thing we're going to want to do is we're going to set the color of this line, because we still are passing this color, but we're not using it anywhere. So to do that, what we're going to do is we're going to actually modify our draw line function here to return this line object. So then we can then set the color outside here. We can either pass in the color value, well, maybe we'll just pass it into here. Maybe that's cleaner. So we're going to update our draw line function to take in our color value here. And so now, after it creates our line, we're going to set the color value to be whatever color we pass into this function. So this color parameter just correlates to, if I go to our line object here, that will equal this property here. We're going to be setting this value here. So now we're going to have to pass that into this draw function. It's this draw line function. So back to our onExplode function where draw line is getting called. I'm just going to pass in this explosion world color. And now you could also, in theory, you could also access this directly inside here. We could do this and not pass it in as a parameter. But to keep this generic, this draw line function, so we can call this from anywhere, we just make that into an argument, so we can just pass that in explicitly here to this draw line function. The only other thing you're going to have to do is, okay, if we hit play, you'll see that all the lines are just going to have their colors updated all at once. Let's see what happens. Oops. Explosion color. Let's see here. World color is equal to that. Oh, right, it's white right now. We're just setting it to white. So if I hit play here and I hit it and I make adjustments to the colors, it is not adjusting the color here. Are we not transferring that in? 1 second. I'm going to go look at the script here. We might not be passing that in. No, I am passing in the color value. But it only does it when you push a value. That's right. Okay, so we're going to have to evolve this. So right now it only transfers the color in once when we push a button. So the color's coming in. So we have to. So if I hit stop now and hit play, you'll see that they'll all be blue. And then if I adjust this and set it to a different color, they're all going to be a different color. But it only initializes it the first time. So we're gonna be randomizing the colors every single time the. Well, actually, no, we can keep it this way, but we're going to make it so that we're going to randomize the color in here, and then before this explosion manager, before we call explode, we'll randomize the color in here instead. So then this will get called every time I hit a button. Basically, every time I hit A, it will choose a new color for itself. So let's do that right now, actually. I'm going to say self.color is equal to RGBA. We're going to just randomize some colors in here. We're going to use the random function, the Lua random function. Random. I'm going to go 0 from 255. for the red R channel, and then for the Y channel, we'll do also random 0 to 255, the blue channel 0 to 255, and then our alpha channel, we'll just set it at 255. And so now it's going to, every time I hit a button, it'll change this color to a random color, and then, because then it passes in, when it calls the explode function, it passes in our color, which we just set to that random color. All those bursting lines will inherit, we'll use that color. So let's see what happens when we play. Throws an error, because I misspelled random. Okay, hit play. So it chose pink, this purpley color. I hit it again, it chose a different color, and you saw that it went and changed all the lines colors to that color, and so we don't want that. And so to fix that, we're going to click on this line primitive. We're going to go to color here, and we're going to detach this from shared copies, because all of these lines are shared copies, so they all share the same properties, and so we have to make sure each line has its own color value that can be set individually, and we're going to just do that by clicking the line primitive and detaching its color parameter. So now I hit play, does that. If I hit it again, those all have a new color now. And hit it again, those all have a new color. And so forth. Okay, so we've now, every time I hit a button, we're going to choose a random color value, and that's the color we're passing into this explode function. So back into the explode function, the explode manager. We are now calling the explode function, which we pass in that color value into here. We're setting it every single time we create it, and we're almost there. One other thing we're going to want to do is maybe fade out those lines after a while so that they don't live on forever, so that we can keep creating these explosions, and then eventually the lines will disappear. And so to do that, we're going to just basically fade ourselves out, fade out the lines that are created by this draw line function. So we're going to update this draw line function to return that copy. This will return whatever line, whenever draw line gets called and it makes a copy of this line object, it will return it as an argument. So that out here on the onExplode function where we call draw line, now that's getting returned in this line object. And it's in here that we can fade out that after a certain amount of time. So I'm going to say fade out and orphan. And the first parameter of this is how long to wait before it fades it out. And I'll do like a 1 second wait time. So again, we updated this draw line function to return the line object that it copies here, so that we can then call additional functions on it. Again, we don't want our draw line function to fade it out, because maybe we want to reuse this function to do other line drawing, and making it fade out is more of a property of the explosion and not the line. Hence why we have this return that line object, and then we do the actual fading in our explosion function. So now so that draw line function returns that line object, and then we call that fade out and orphan. And then this is the amount of time it'll wait before it fades it out. Let's see what happens. Hit a button, and then after a little bit of time, they start to fade out, the lines. So we're going to speed this up now so they explode out all at once. And to do that, we just need to go in and adjust that. There's actually two time values that are occurring here. There's this add key, that this is the amount of time it takes to animate the burst, and then there's the amount of time it waits between individual lines bursting before it bursts another one. So the first one here in this add key function, the draw line function, I'm just going to make this much faster, and I'll do a 1/100th of a second. And then we can wait again 1/100th of a second to emit each line. So now it should be much faster. And then they fade out after a second. So now we have this kind of cool thing that we can move around. Every time I hit a button on my keyboard, that will explode out, that will create that kind of burst. Let's make it a little bit more look more like light. Right now we're kind of in this light environment, so we want to modify the material basically so that they look more kind of like more neon-y and more light-like. So by default, our line object is using this default material, so we could either modify this default material, which I guess we'll do just for simplicity's sake. I'm just going to click on that default material, and then under illumination, we're going to set the emissive amount here to maybe 100 or like 150 or something kind of bright. So now when we hit play, you'll see that they all have this brightness to them. They're more like light every time I push this button here. And the other thing I'm going to do is I'm going to click on the sky, and then I'm going to set night sky to true here. This is a property that lives in the sky space that you can get to by clicking on the sky, and I'm just going to set this to true. So now we're in the dark. We'll see it a lot more light. And then they fade out. So now we have this basically this function that lives in the explosion manager that will create this explosion, and we can call this from wherever we want. We can call this, in this case, whenever we push a button. We could maybe call it on a timeline in script. We could also, for instance, we could animate this back and forth in the space. For instance, if I go to the transform here and I add a signal to animate this maybe along the x-axis, I'm going to create a new signal controller, and then I'm going to create a new waveform signal. This is going to move the object along the x-axis, 30 units along the x-axis when we hit play. Now every time I hit a button, it will burst wherever it happens to be, which is kind of neat. We could also create a script track here. I'm going to create a new script track, and it's going to wait maybe 2 seconds. And then after 2 seconds, we could have it emit wherever this happens to be. Or we could just have it create an explosion. If I just drag and drop this explosion manager directly into here, I can just call explode and just pass in our own parameters here. I'm just going to say explode and then pass in a vector 3. We can make this wherever we want. Maybe the center of the world, a little bit above the ground. And just give it our own color here, RGBA. We'll make it red, 255, 00, 255. So now, after 2 seconds, it will just create an explosion at this location here, at location 010, and using that color. So let's see what happens. I'm actually going to remove this animation here from this signal controller just to kind of simplify this. Hit play, it's going to wait 2 seconds, and then there it is. It emits that there. Because we have this nice centralized location, this explosion manager, that we can kind of now use in lots of different contexts to create our explosions. So the other way I wanted to show you how to do that is to create an explosion on a collision, basically. So we're going to call this explode function, but we're going to do that whenever something collides, hits the ground in this case. So we're going to create our object that we're just going to create a simple sphere here, and whenever this sphere, and notice that it glows because it's using our default material, which we cranked up, which is fine. Whenever this sphere collides with the ground, we want it to create that explosion. So how do we do that? I'm going to go into the library here, the browser. I'm going to right-click and create a new collision model right under collision models, and then I'm going to double-click this collision model. I'm going to create a new collision detector. I'm going to hit this little plus button, and I'm going to hit new impact collision detector. We basically want to detect whenever it impacts something, not when it rolls or slides, but when it impacts. And then I'm going to expand this new item that was added, and it wants a collision response. What happens if this impact gets detected? We're going to create a new script collision response, and that basically says call some script every time a collision impact is detected. And then on the right side, we're going to implement this onBegin tracking function. So this gets called whenever the collision is first detected. OnTracking is called while it's colliding, and then onEndTracking is called when it's done colliding. So we're interested in just doing it when it first collides. And inside here, we're going to just find our script, our explosion manager. I'm just going to drag and drop that into here, and we're just going to now call that explode function with the location of the collision, which is actually stored inside this collision info. So if we select onBegin tracking, hit F1 on it, we get our documentation on this onBegin tracking function, and it receives this first parameter is this collision info object. If we click on collision info, you'll see all of the parameters that are passed in here. You can think of this as a snapshot of the collision. When a collision happens, the snapshot is passed in to this collision info object. And it's through here where we can find the collision location, which happens to be this world position on A. So I am going to just say explode, and we're going to say collision info, and it's world position on A. And then we got to pass in a color. So we can actually use the color of the object that's causing the collision, which in this case is the sphere. So to get that, going back to our documentation, that's actually going to be inside body A. So body A is a rigid body, and then from there we can get its parent to get the actual object. So I'm going to say collision info dot body A get parent, because the rigid body is going to be this object here. We want its parent object because that's where the color lives on there. So we're going to get its parent, and we're going to say dot color. So whatever the color of the object is at the moment of collision, that's what we're going to create a collision around at the location of the collision. So I'm going to close that. I'm going to hit play, and if I give it a fair amount of force here, nope, it looks like I'm going to get rid of this animation here, this time-based animation. Oh, right, and the other thing I forgot to do here is we have to take that collision model that we created, and we need to drag and drop that onto our object here to assign it to the object. So we created it before, and we set up all that logic to call it, but we actually have to assign that. You can think of this as a material, and we need a collision, the material that defines like collision response, and we need to actually assign that to the object. So we just drag and drop that onto the sphere. And what that actually does is if we click on the sphere here and go into rigid body, it assigns it as this collision model here. Okay, so now when we hit play and it collides, it creates that explosion effect wherever it happens to hit the ground. And so since it inherits the color of this sphere, if we just animate the color of the sphere, we'll get lots of different colors as it hits. And so to do that, I'm just going to click on the sphere here. I'm going to go to the color property. I'm going to click this, this little arrow button here, the menu button, and I'm going to create a new color component attribute. And that adds this new thing underneath it that lets us set the color via hue, saturation, and brightness. And I'm going to set the saturation all the way to 1, so it takes on that full saturated color. And so what we want to do is just animate this value here. So I'm just going to create a new signal controller, and then I'm going to expand out that. I'm going to create a new waveform signal. And so this is just going to go back and forth on a waveform. And we got to set the amplitude to 180 because it's going to take this parameter here, which goes from 0 to 360. If we set it to 180, it will now go from 0 all the way to 360 when we hit play. And so now when it collides, whatever color it happens to be, it will make an explosion of that color. So like that, makes it yellow, green, and so forth. A couple other things that we might want to do to tweak this to make it look a little bit nicer is we're wasting a lot of our lines underground in this case because there's a bunch going underground and we want to see them kind of all above ground. So we can just write a little bit of simple logic in here to kind of prevent those lines from created underground and instead always make them appear above ground. So under the terrain space, I'm going to go find our explosion manager. And basically here where we calculate our end position here, which is like take our world position and add in that random vector. If its y value is less than 0, we'll just flip the sign. We're just going to take the end of that. It's just going to be equal to that times -1. So basically, if the end position is underground, we're just going to take that position and just flip it so it's above ground. So now all of the rays will always appear above ground when we're hitting the ground. And so now it looks a lot more fleshed out. And another thing we can do is we can make this ball bouncy so that it can kind of bounce and keep going and generating more. And so to do that, I'm going to select it, go to the rigid body. I'm just going to set the bounciness to like 0.6. Don't set it too high because basically this value is how much energy is transferred into a new, is kind of injected. How much energy of the impulse, of the reflection impulse when it hits, when it collides with something is injected back into it. If we make this greater than 1, it's going to actually have more strength than went into the, it's going to actually have more energy will come out of and reflect than went into it basically, so it's not really realistic. So we want to make sure we keep it under 1. So now it's going to bounce, and then we can kind of get that repeating effect here as it bounces. So now if we create a node emitter, we can have it emit these spheres. I just created a new node emitter. I'm just going to take it and rotate it just a little bit over there. And then under the node emitter's properties, I'm going to go and pick for its sample this sphere that we just created. And now it will emit these spheres, which in turn will collide. So I'm going to just stick this close to the ground here so that it doesn't cause an initial explosion with that in the distance. And now it's going to emit, and then they're going to explode every time they hit. So now we have this kind of fun, explosion-y, kind of crazy light show. We can keep adjusting parameters on the material. We can play around with different colors, but it's a neat effect that kind of you can kind of use in a lot of different contexts, a lot of different ways. Basically, this and it's very reusable. And the other really useful thing out of this here is just draw a line. And you saw how to make that line. We had to create that cylinder and kind of set those offsets and those adjustments via the vertex transform of that cylinder to ensure that we're able to just call this lookat function and set the world position to make it kind of just all work really in a very elegant, straightforward way. So that wraps up this tutorial. I hope you enjoyed it, and we'll catch you next time. Thanks for watching.